Question 12, Part C. A person walks 2,000 meters due north along a road from point A to point B. The point A is due east of a mountain OM, where M is the top of the mountain. The point O is directly below point M and is on the same horizontal plane as the road. The height of the mountain above point O is h meters. From point A, the angle of elevation to the top of the mountain is 15 degrees. From point B, the angle of elevation to the top of the mountain is 13 degrees. Part 1. Show that OA equals h cot 15 degrees. Consider triangle OMA. Now I've sketched that triangle here. We have a right angle here, angle MOA. Now the height of the mountain is OM, which is indicated with the lowercase h, and the angle of elevation from point A to the top of the mountain is 15 degrees. So we can use regular right-angled trigonometry or SOHCAHTOA to come up with an expression for OA in terms of h. So opposite over adjacent is equal to tan 15 degrees. So h over OA is equal to tan 15 degrees. Taking the reciprocal of both sides, we have OA over h is equal to 1 over tan 15 degrees. Now 1 over tan 15 degrees is cot 15 degrees. So multiplying both sides of the equation by h to make OA the subject, we get OA is equal to h cot 15 degrees as required. Part 2. Hence, find the value of h. In triangle OMB, OB is equal to h cot 13 degrees for a similar reason to part 1. Now let's consider triangle OAB. That's the triangle on the ground. Now it's a right angle triangle for starters, and we do know the length of one side. Side AB is 2,000 meters. Now the hypotenuse OB is h cot 13 degrees, and the other short side, OA, is h cot 15 degrees, which is the expression that we found in part 1. So we can use Pythagoras' theorem to find the value of the one variable h, which is used twice. So using Pythagoras' theorem, we have hypotenuse squared minus short side squared is equal to the other short side squared. So h squared cot squared 13 degrees minus h squared cot squared 15 degrees is equal to 2,000 squared. Factorising out h squared on the left-hand side, we get h squared outside of cot squared 13 degrees minus cot squared 15 degrees in brackets equals 2,000 squared. Now I'm going to rearrange this equation to make h squared the subject. So I'm going to divide 2,000 squared by what's in the brackets here and here. So by cot squared 13 degrees minus cot squared 15 degrees. And I've written that here. So h squared is equal to 2,000 squared divided by cot squared 13 degrees minus cot squared 15 degrees in brackets. At this point, I'm going to evaluate the right-hand side, since I'm going to round this later on to the nearest meter. And we get h squared is equal to 827,561.0914 and so on. Taking the square root of both sides, we get h is equal to the square root of 827,561.0914, which evaluates to 909.7038482 and so on. And rounding that correct to the nearest meter, that's 910 meters. Therefore, the height of the mountain above point O is 910 meters, correct to the nearest meter.